Hi, good evening. This is about the initial configuration of Cisco SD-WAN. It involves several steps, and um, here we talk about how we set up and manage our SD-WAN environment built on Cisco. So first, we set up the controllers. We deploy vManage, vBond, vSmart controllers. So we first download the appropriate software images from Cisco website and then deploy vManage, vBond, and vSmart controllers in your virtual environment. Then step 2 is to perform the initial configuration of vManage, where we access vManage a graphical user interface through web browser and complete the setup by providing necessary information, including system IP, host name, and organization name. Step 3 is configuring vBond. We also access vBond via CLI, command line interface. We set the system IP, site ID, organization name, and configure the tunnel interface. Then we configure vSmart via command line interface. Set up a system IP, site ID, organization name, and configure tunnel interface. Next step is establishing control connections, where we generate CSR. CSR stands for Certificate Signing Request. We generate CSR for vManage, vBond, and vSmart. Sign in the CSR with your certificate authority, which is CA, or via Cisco's certificate authority. We install certificates, install those signed certificates on vManage, vBond, and vSmart, and configure vBond IP on vManage and on vSmart. Step 3 is adding and configuring WAN edges. Cisco WAN edges, we add them to the WAN edge list. In vManage, we navigate to configuration, devices, WAN edge list, and add WAN edge routers, including device serial numbers. We are deploying WAN edge devices, installing and powering on the WAN edge devices at their respective sites, connecting WAN edge devices to the internet, and performing initial configuration for WAN edges, accessing WAN edges through command line interface, configuring system IP, site ID, and organization's name, and configuring tunnel interface. Step 4 is establishing data plane connectivity. Here we configure TLOCs, which are transport locator. In vManage, we go to configuration, devices, device templates, and create a template for WAN edge devices. Then we define TLOCs and attach that template to the device and establish IPsec tunnels. We configure necessary parameters in the templates, and vManage, we push the configuration to the WAN edge devices. Step 5 is configuring policies and application-aware routing. First, we creating policies in vManage, and we create centralized and localized policies if they are required, applying them to appropriate sites and devices. And we configure application-aware routing based on your requirements and apply policies to ensure optimal application performance. And the last but important step is monitor and troubleshoot. You monitor the network using vManage dashboard. vManage dashboard allows you to monitor health and performance of SD-WAN network. We check the status of control connections and data plane tunnels. And troubleshoot, we use different commands. I will tell you more in future series about SD-WAN for Cisco. So let's continue where we stopped last time with vManage. It sets up in clusters, and we could split and choose a person for a single vManage deployment, choose the storage devices. vManage boots up for the first time. When it's booting for the first time, we can choose those storage devices. We can deploy OVF templates. OVF stands for Open Virtualization Format. SSD physical storage is required for normal vManage performance. And here we perform initial vManage configuration via command line interface. So here we write conft, which is for configure terminal. Then we type system, host name, and we put the name vManage. We state here system IP with the IP address, site ID with the number, for example 1001, organization name, vBond. Also in vBond we put IP address and DNS name, and then commit complete. Management access VPN 512. We set it up also via configure terminal, VPN 0. Configure VPN 0. Here we put no interface Ethernet 0, VPN 512. Then we put in configuring interface Ethernet 0, interface Ethernet 0 and its IP address / prefix, for example 24 for subnet mask 24. Here we put also to enable this VPN interface, we put no shut, no shutdown, and exit. And then we configure VPN 512 with IP route, which is default route 0.0.0.0/0. And here we put that IP address to which we are doing the default route, commit and quit, and commit complete. We can access web interface and system settings in administrative settings. Here we put organization name, vBond, configure the names. After initial configuration is applied to vManage, we need to access the vManage graphical user interface to confirm the organization name and vBond IP address. Certificates for controllers. First, recommended, of course, CA, which is authority, which is Cisco CA. It's recommended automated certificate signing through Cisco. But we have another option. There are 4 options for that. Second option is automated certificate signed through DigiCert. vManage reaches through DigiCert, but I think that since March 2023, DigiCert might be not supported, no longer supported, unfortunately. So the second option is not an option anymore. Third option is manual certificate signing through Cisco. So you can have like automated certificate signing or manual. And the fourth one, if your company uses your own certificate authority, enterprise root CA certificate in special format, vManage automatically distributes the root. So a root is centralized to vBond and vSmart. They could be like CSR, which is Cisco. First step is we retrieve root certificate. Second step, we upload root certificate from vManage. Then we initiate CSR. Step 5, we download copy CSR. And step 6 is manually submit certificate request. And obtain certificate, retrieve signed certificate, upload certificate, certificates installed on vBond and vSmart. You can deploy OVA template, vBond installing using vEdge Cloud OVA. OVA is pre-configured with 4 network interface cards, 4 NICs. We can perform installation of vBond. So how we do it? In system settings, we put host name vBond, put system IP, put their system IP address, put site ID, put any site ID, for example 1002, put organization name, organization hyphen name, and put here name. Then vBond, put IP address, local. This keyword defines the vBond role, and commit and quit. Strong zone-based security controllers. there is a strict separation of the management and control planes, and this separation enforces a strong security zone model. Configure vBond transport interface. Settings for vBond transport interface. VPN 0 is pre-configured for WAN transport using DHCP and IPsec protocols. Tunnel prevents incoming netconf, CSP, or SSH traffic. To configure vBond, we put tunnel-interface, no allow-service, and here we put no allow service SSHD, and no allow service netconf. vBond interface, and put the interface, for example, gigabit Ethernet GE, let's say 0/1. We put interface considerations, and VPN 0 interface is pre-configured for WAN transport, DHCP, or IPsec. And it is recommended, for example, we put that interface and configure it, let's say interface gigabit Ethernet 0/1. We put no tunnel interface, tunnel-interface, and disable tunnel interface for initial system bring up. The tunnel interface VPN 0 is a preferred way. Not to forget that here net translated private IP addresses. They turn in those services, and network does not work without tunnel interfaces. So we should allow only VPN 0 on that gigabit 0/1 gigabit Ethernet 0/1 interface, allow only VPN 0 tunnel, and allow only special protocols. vSmart, it obtains software and verifies system requirements. Initial configuration is hostname and NTP. NTP stands for Network Time Protocol. System IP makes sure that you size the virtual machine accordingly with overlay network, design, and scale. We put site ID, VPN, organization name, transport configuration VPN 0. If you use enterprise certificate authority, then which exists in customers' existing infrastructure, here we have node ID, name and organization, node public key, and signature from certificate authority. Certificate has the information about the owner. Convenient certificate authority setup for lab testing could be XCA, TinyCA, OpenSSL, library part of most Linux distributions. Validating peer node certifications. Node enroll and get their own certificates. Add vBond and vSmart to vManage. We show certificate root CA certificate. So it's root dash CA dash CERT, and show certificate installed. We generate CSR certificate signing request. To enroll the controllers with the certificate authority, you must generate CSR for each controller, then transmit the CSR to the certificate authority. We generate and download all 3 CSRs to this local certificate authority, and then sign the CSR, create actual certificates as required, and then validate them. You can create the certificate. You can either browse and select and see if it worked or not. To browse and select, you go to Configuration, Devices, Controllers. You can configure VPN 0 for operation VPN 0, vManage, vSmart, and vBond. And to configure that VPN 0 for operation, we go and configure interface. Let's say it's Gigabit Ethernet 0-1 or 0-0. Put tunnel interface, tunnel-interface, encapsulation IPsec, but it is uses DTLS. So we put their configuration IPsec, but that IPsec uses DTLS. Verify control connections. If they are successful, import the certificate. Go to Configurations, Controllers, Certificates. In the vManage command line interface, DTLS connections are established, and you can use command show control connections. You will see if connections are established with vSmart and with vBond. Controllers placement and challenges. There are several challenges, for example, for reachability and for network address translation. By default, WAN Edge routers try to establish control connections all over the provisioned, and you can control which transports the WAN Edge routers use to establish control connections, such as global, device-specific. They could be like cloud controller connections, cloud-hosted controllers, MPLS, internet connectivity, control data plane establishment. We separate underlay disjointed, and all controllers must be IP reachable from all devices, and they need to be able to reach each other. Control data plane establishment. So here we use vBond, vSmart, vManage. They go through control plane connections to internet or to MPLS, and Cisco recommends cloud-hosted deployment for SD-WAN controllers that we cannot get to bond via public address. We need to set up vBond via the IP address that has the public addresses. It would be netted and have to be mindful about the reachability. So if there is no reachability to the internet, like eNet, through a second transport, there is no control connection redundancy. So there should be reachability via all methods, like both through MPLS and internet. And vBond and NAT traversal on premises deployment. So on premises deployment, controllers can support hybrid, private, or public transport connections. There are colors, as we talked in the previous lecture, what are the colors, and they should be matching. Colors should be matching, and this is crucial. So first, do your homework, and then you can figure out which color for which connections. And if there is multi-homed WAN Edge routers, they're capable of supporting both models concurrently at the same time, both models. Firewall protecting edge port essentials. There is device helper. Firewall configuration must allow traffic to flow from firewall to the edges, to the WAN edge to controllers, from edges to controllers, and from controllers to edges. So firewall should allow connection from the edge to the controller. How we onboard WAN Edge devices. We first upload the WAN list. In typical task, we don't validate all of them straight away. Validating means that WAN Edge routers can connect without further human control. If there is in the box is not checked, each device must be validated individually to join the network. Importing a WAN Edge list. Task view. If tasks are successful, then we see special ticks there, green, like a check mark green. Certificate installed, check mark green. Device onboarded, check mark green. Bootstrap configuration generated, token generated. We can view the full list of WAN Edge routers. Deploying vEdge cloud devices. vEdge cloud system requirements. It should be verified before the deployment. So we verify memory, which is required for the deployment, disk space. There should be minimum 2 cores with 2 GB RAM, and 1-to-1 ratio core to RAM. Obtain software, deploy OVF template, perform initial configuration, install root certificate, and then activate vEdge Cloud. VM interface mapping, vEdge Cloud. vEdge Cloud is to be connected to the correct VLAN. So we can see the list with vNICs, interfaces, VPNs, and if DHCP is enabled or not. Performing an initial vEdge Cloud configuration is in VPN 0 and configuration. We put the system, VPN 0, transport configuration includes IP address. There we put IP address / subnet mask. Tunnel dash interface, encapsulation, IPsec, color, let's say for example color MPLS. Then exit, no shutdown, and then exit. You can, at the end, we put commit and quit. It's via command line interface. Copying and installing the root certificate authority. On vEdge Cloud, local properties before bootstrap configuration with enrollment information. Here we identify to include chassis number and OTP, one-time password, token, so serial number can be generated for each device. On Cisco vManage, under configuration, we go to devices and then to WAN Edge list. Activating vEdge Cloud. To activate the chassis number, we use UUID and OTP token. When we are activating WAN edges, we have only hardware appliances. vEdge doesn't have that chip inside as trusted source, so use that OTP. Verifying vEdge Cloud activation. You can see if WAN Edge router is enrolled, view its host name, system IP, site ID, no data active data planes connections with other routers. BFDO has established that amount of sessions you can see there, and you go to configuration and then go to device to see it. Verifying the device certificate is installed and valid. Like final step there, data plane connectivity established confirms that there are currently no data plane connections to other ES. Deploy Cisco Catalyst. They could be for different models, different paths, how we do it, but generally devices, they could be like hardware versions and like virtual machines devices. So here For that deployment, we first obtain software. Second, we use OVF template and maybe extra network interface cards. Step 3, we perform initial configuration. Step 4, root certificate, root CA certificate. Then step 5, we enroll to vManage. When we are using the mapping for default mapping, we use show version, include mode, use command controller - mode enable. This command will use default mode for the routers, and it includes in, for example, iOS XE SD-WAN. And when we are changing from autonomous mode to default mode, when setting the bootstrap properties, you can choose which VNIC will map to the router's management interface. We perform initial configuration, for example, Catalyst 8000V. Here in configuration, VRF management interface, we put management access, which interface description, put the description, for example, this is a management interface, put IP address, and then put subnet mask. Then put no shutdown to enable this, and commit exit. Transport configuration interface. We configure that interface, for example, Gigabit Ethernet 2. Interface tunnel 2, IP unnumbered Gigabit in Ethernet 2, tunnel source Gigabit in the Ethernet tunnel, mode SD-WAN, interface Gigabit Ethernet 2, tunnel-interface, color MPLS, encapsulation IPsec. When we configuring Cisco Catalyst 8000V, root CA and vManage enrollment, we generate and then copy UUID and the token. And we activate router's chassis number. Copy root certificate to Catalyst, boot flash, and then install CA and OTP token. Then we verify vManage enrollment and activation on the vManage dashboard and WAN edge device reachability. We check SD-WAN control local properties, verify control plane connectivity, ZTP process overview, pure play. viptel operating system. What is ZTP? ZTP stands for Zero Touch Provisioning. ZTP process has these characteristics. Public ZTP vBond can redirect to cloud-hosted or non-premises controller. New devices are linked to the organization using vSmart account. And additional devices can be associated with the customer using plug-and-play Connect portal. We will continue tomorrow. Thank you for your attention. It's time to go to bed.